Hello everyone, let me introduce myself. My name is Jakaria. I'm first semester NCK student, and in this video I'm doing an interview through the Prime app. In this video I'm an interviewee and interviewer. The topic that will be discussed is the array of array products and key method array. Okay, let's go to the video.
Hey, can you see me?
Yeah.
Yeah, we good. Okay. So I'll just go through the question and I'll just explain the question to you. I thought you knew about that question. All right. So this is a question for you wherein you'll be given an array and
Wait.
you have to return an array wherein it's the value at each point. It's the product of every element apart from the element at this index. So for example, this 20 comes from 10 into 2. You'll be given an array. Does
Okay.
it won't be sorted or anything. And if you can see my screen, right?
Yeah.
So this the given array is 8 comma 10 comma 2 for you. Now what you
Okay.
need to return is another array of the same size, but
Okay.
every element in that array is gonna
Okay.
be equal to the product of every other element in the original array apart from the element at this index. So for example, 20 here comes from 10 into 2, which means that since 8 was at the index 0, so we don't include it, but apart from that we have 10 and 2 and you multiply them and the 20 is over there from that. For the second index, for the like index number 1, for the second value, the 10 comes from shouldn't be 8, it should be 16. Yeah, my bad. Yeah, the 16 comes from 8 into 2.
Okay.
So you don't include the element at the index number 1 over there. Similarly, the 80 over here comes from 10 into 8, so we don't include a 2 over here, and that's what we need to return. The catch is you cannot use a division operation.
Okay. So its meaning is like the the input is will be array, then is will be here h 10 and 2, right? Then is mean is will be h multiple 10 and multiple 2. It's like that,
No,
and that's
uh, 8 multiple 10 multiple 2, what was the like, you don't multiply everything, you multiply,
yeah.
you won't include 8 while multiplying 10 and 2 in
But
this one.
that's will be have create prefix and suffix and of the length and of I is for the original array.
Uh-huh.
So that is will be every index is will be update a prefix for the index. Then this array is will be store the product up to I minus 1 from the index start of array. Do
All
you
right,
get it? What you?
we can go through your solution, I guess.
Oh, you
Uh-huh.
can see my pointer.
I guess, yeah, at the it's at the last bracket, I suppose.
Oh, okay. So
Uh-huh.
from this array, it will be have create to array for the prefix and the suffix of the length of n.
Uh-huh.
Then the length of the original array for the initialization prefix is mean of the
Okay.
prefix is 0
Mm-hmm.
equals 1 and the suffix is for the array n minus 1 and that is equals 1. And also for another array to store to the product. Do you know what
Yeah,
I
yeah,
mean?
I get it.
Okay.
I get it. Good. You
Then
can, yeah, that's good. So you can kind of like, I guess if you wanted to take a very small example and kind of show me how that works, or you can start coding it. I get your point. Though that you have an array, you have a prefix array, you have a suffix array. Prefix of 0 is 1, suffix of last element is 1, and then for the prefix you kind of multiply everything from left to right. For the suffix you multiply everything from right to left, and then you multiply them together to get the results. So I think it works.
sure. Yeah,
Yeah,
yeah.
makes
So
sense.
now I can start from the write code.
Yeah, you can do it.
Oh, okay.
Yeah.
That is for the n and equals the array data and the length. So it means is in here is no need for here. Okay. Then it will be n as no. That is will be have condition in here is n equals 0 or n equals 1. Then in series will return the n as no ent index 0. That is will be return index 0 in here. I mean in this condition. Do you got it?
Why will we, like, if n equals to 0, then it means that there is no 0 index, right? So we can
Yes.
just return the array that we have given, and that should work, right?
Okay. Because that is in here should be integer also. Integer array and the result is called new integer for n. Is for the length of the array. Okay. Then for the calculation the left and the start in the result. So it's mean int left I left 1. So this is for the calculation and that is will be have the looping in here. So for in I equals 0 I great n, so that this will be I plus plus, then this will be have the result index I then this is will be equals left, then this will left multiply the array int x. This process is for the calculator left and the store in the result.
Makes sense.
Okay.
But I guess the syntax is a bit problematic because after I plus plus you have an open bracket but not a like circular bracket.
Which index you mean?
The line number 12 at the very end after I plus plus, you have an opening bracket. It's syntax error, I guess.
Indexes?
Line number 12
Line number
at the,
12. Okay.
at the very end.
Oh, yeah. Sorry. I forgot. Okay.
Yeah.
So the next step is to calculate the right and the product from the end of the array. So in here is integer right is 1. Then there will be same also is have the one looping, and that is integer e is equals n is for the length, then is the minus 1, then is greater than 0. Okay, then that's e min minus. Okay, then it's here for the result from the index array. So that's the right, then the right array I. So that's for the calculation right, the product from the end of the array. This will be in this function. Then that just will be return the result. So that's just for my opinion for the solve this problem.
But oh, okay. I don't think. Okay, so can you iterate through an example for this? Like show me kind of how it works. So let's go through this example. So um, let's go through this example. So can you kind of iterate and see how result is working?
Oh, you mean I need to explain how that is will be works?
Yeah.
Oh, okay. So this this is like the mean, that is the number, right?
Mm-hmm.
Okay. Then is will be have left and the right. Okay. So it's mean is 2 and there's 2 multiple 7 and 2 multiple 7, then multiple 3 for the left. Okay.
Uh-huh.
Then the right is will be,
But the thing is, you'd have the same array, right? So you are just modifying the same array. You just have one array which is result, and firstly
yes.
you're going through the left and multiply everything to it. But
Yes, yes.
then you're doing the same thing from the right. But then you're not working on the same array, right? So when you're starting at the right, it will not be like, well, I guess like you needed two different arrays, one for the left and one for the right, and then you needed to multiply them together.
Yes. But regarding for third array, I mean the third number of the array, the product array is you will expect is like 2 multiple 7 and multiple 4, which
True,
consistent of the part of
true,
left
true.
is, sorry, is 4.
Huh.
So
Makes
it's,
sense.
so which mean the consistent of the parts left is 2 multiple 7 and right is 4. Then the product is left multiple right. We can get the left and the right. Okay.
Makes sense. Makes sense. I think that could work. We can, yeah, we can work through it.
Okay. So that is my from the my explanation for the solution, and that is my implementation in the code is will be like this.
Okay. So we can dry run it, I suppose. So I'll just cut this from here. I'll just paste this from here, and yeah, I think, yeah, we can click on run code if you want. Run tests. Yeah.
Okay,
See,
that is will be,
everything works. Yeah.
yes.
So yeah, I think we're good.
Yeah. So like, because I think that's for the in this function it will be relate as I mentioned to you before. I this function is will be relate like what I told you before.
Yeah. This is exactly like that, and it works. So yeah, this is the best solution possible.
Okay, okay.
Yeah.
So that is my opinion for this problem.
Yeah, it's good. It's good. This is the optimal solution, and I guess this is the best solution you can come up with. I can kind of explaining your solution, right?
Yeah,
Try
yeah.
to do it with some examples. So try to iterate through exactly what will be happening, especially when you're just telling the person your approach. So try to do it like, okay, this is gonna be the array. I'll create one left array. Like I'll have a left variable. I'll keep on multiplying everything from the left to the right. Then I'll do that from right to left, and that will give me a solution. And this is the reason why this will be the solution. So maybe kind of spend a bit more time on explaining that part. So other than that, like your code is pretty clean, I think, and I guess you found a pretty optimal solution pretty fast. So that's pretty good. But I guess that's a bit. Okay. So I'll just go through the question, I guess. Given an array of integers where each element is at most two places away from its sorted position, write efficient function that sorts this array. Okay. So for an input array of size 10 and k equals 2, um, would either be 4, 6, 7, or 8. I see. Okay. So I am given an array,
Okay.
and I need to basically, and I'm given an integer which is k, which is equal to 2. What this says is that every element that is present in the original array is
Okay.
at max two places away from where it is actually supposed to be in the sorted order.
Okay, okay, okay.
So if I had sorted this array, then this the value at index 0 would at max be like this one could either be at over here, or it could be at index 1, or it could be at index 2. Other than that, this one will never be at any other place in the sorted array.
Okay,
So
okay.
that is the question for me. So if k equals to 2, right? So one can be over here, or one can be over here.
Yes,
Um,
okay.
Just give me 1 second. Belonging to index 6 could either
So
be okay, or it can be over here, since two places ahead and two places before it. So other than these three positions, k cannot be anywhere else.
okay, okay.
Similarly, 4. So 4 can be over here, 4 can be over here, 4 can be over here, and 4 can be over here. But other than this, like 4 cannot be at the at the like the next index, because k equals to 2, and in the original array its index is 1. So 2 ahead it and 2 below before it, if like you can fit 2 before it. So for the 5, 5 can be over here, 5 can be over here, 5 can be over here, um here, and I guess here. But other than this, 5 cannot be at any other place. 2 and 2. So since you see like 5, 2, there are two indexes before this and two indexes after this, right?
Yeah,
So
yeah.
that's why 5 can be in either one of these 5 places. Now when you come to 2, now this 2 cannot be at the 0th index. This 2 can be over here, 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 or here. So because 2 before this and 2 after this. So at the end, what I need to do is to sort this array, right? So in order to sort this array, I I will have to choose the minimum at the 0th index, minimum of the possibilities at 0th index. So minimum between 1, 4, and 5. So 1, 4, 5, the minimum of these, which would be 1. So my
Yes,
first
okay.
element would be
Yeah,
1.
yeah, you will get the minimum first, right? Okay. Then
Yes. Now I will remove 1 from my list of possibilities. So for the index number 1, I have the options of 4, comma 5, comma 2. I
okay.
will choose 2, which is the minimum.
Okay.
I will remove 2 from my list of possibilities. So 1
Oh,
and 2 are removed. So
yes, yes, yes.
for the next one, I have two options, 4 and 5, right?
Yeah, yeah.
So for this one, my answer will be 4. For the next one, I guess which one was, I have three are done, right? So for the fourth one, I suppose like this is how it will keep on going, and I will have 5 over here, and then I guess I'll just keep on going like this, list all the possibilities, and keep on choosing the minimum of these possibilities to get my answer.
Okay, okay. Nice, 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 nice.
I think a possible way to for me to keep choosing everything which is the optimal every time would be to keep all of these things in a priority queue or a min heap. So I will initially create a min heap, I suppose of length um k, or okay, maybe like 2 times the k, I suppose, and I will add um okay. So I need to have everything. Okay, I will start with this. I will add the first 3 elements to my mini heap at the very beginning.
Okay.
And yeah, I think.
But wait. Why you not use the insertion short method? Like that is really 1 and 4, 5, 2.
Yeah, I can choose insertion sort, and I could just use like, I don't know, merge sort and sort this, right? I
Oh
don't
yeah, yeah,
even
yeah, yeah.
I don't even need to use this information, but that will not be the most optimal thing for me to do for this solution,
Okay.
because probably the value of k, it's gonna be for this one, right? My solution would be order of n log k,
Oh,
wherein
okay, okay.
if I do insertion sort or merge sort or anything like a normal sort, it will give me order of n log n. And
Okay, okay.
that is and since k is supposed to be less than the array length, if you see in the over here as well, right? K is between 0 and 20, while array is between 1 and 100, and
Yes.
that's why this is kind of a better solution for me.
So you mean why you not choose the insertion short? Because that is will be more than better than the insertion short, right?
Insertion sort will be n log n, right?
Yes. Then your your answer is done is more than better, right?
Yeah,
Okay,
it's
okay.
or my answer over here is order of n log k, because I
Okay.
will be maintaining a heap of length k, and every time I add anything to that heap, it will
Okay.
take order of like logarithmic time. That's why it's like, and I will have to I guess go through the heap, and I'll go through the array and keep on adding elements and removing elements from the heap, but the maximum size of that heap is gonna be k, and that is probably why it's gonna be n log k, not n log n.
Okay, okay, okay. So maybe now you can explain it in the program. You can
Yeah,
write
for
the
sure.
code. Okay, okay.
Yeah, I'm just kind of like thinking about how to make the heap work right now. So that's why I'm just kind of thinking of my brain. So because I just need to see what does my heap start with.
Okay.
Yeah, so just I'll just have one or two more examples over here, so it will make things a lot clearer for me. Okay, so I think I can add um k plus 1 elements to the heap at the very beginning.
Okay. Then.
And okay, this is what I can do. I can add k plus 1 elements to the heap at the beginning. So k, since k is 2, I'll add 3 elements to the heap. So my heap is at the very beginning. It has 1, 4, and 5. And
Okay.
my this thing is over here. My, like, a pointer for indexing and for looping, it's over here. I is over here. Now for every point, every I will choose the minimum element from this heap. So I will choose 1. I'll go here. I increment my I,
Okay.
and I add, since I see um two I need. Okay, yeah. So since I see a 2, I add 2 to my heap. Then sorry, this is 1. Then since I like printed 1, I guess like remove 1 from the heap, add to the heap, because value at I is 2. Then increment again, add 3 to the heap, and push it again. So I think this will work.
Okay.
Okay, I can start coding now.
Okay.
Do you have any questions for this one? I can start
No,
coding.
no. You can start first.
Okay,
Okay.
okay, okay, okay. Priority to teacher heap equals to new, or the queue of size. I think k plus 1 should work. Okay. I'll just check the syntax for priority queue over here so that I make sure I'm writing the correct thing. Priority queue Java. Yeah, I think the initialization is good. Okay, good. Okay, we're good. Yeah, so we have the heap. Now for the initial things, int I equals 0. I'll have I over top, I suppose. 0. For I equals 0. I'm just adding the elements to the heap right now. I is less than or equal to k. K is 2 in this case, and I need to get to index 2. So yeah, this is good. I plus plus heap dot add heap dot add array of I.
Sorry, I think you wrong the put something in here.
Yeah, I wanted that variable to be public because I will be
Oh,
using it
okay, okay,
afterwards
okay,
as well.
okay,
That's
okay,
why I
okay,
put
okay,
it.
okay. You just put
Yeah,
in public. Okay, okay. It's fine.
because I wanted it afterwards too.
Oh, okay.
Okay. Int result. But I can probably change the same array and return it again. I don't need to change the. I'll just do that, I guess. So for int j equals 0, j is less than array dot j plus plus Mm, if I is less than array dot length heap dot add array of I plus plus. But before this, I need to add this element. I need to pull it in smallest element equals to heap dot poll, and and what is the next thing that I need to do? I need to, yeah, push it over here. So array of j is equal to smallest element. Okay, and over here I just return my. Let me iterate through this and make sure that what I've done works. So what I'm doing at the initially I'm adding the first k plus one elements to the heap. So for in
Okay.
this it's in this instance, if say k was 2, right? So I'm
Yeah.
adding the first, like from index 0 to index k, so which means three elements in total, 0, 1 and 2. So I'm adding 1, 4 and 5 to the heap at the beginning, right? So after this line, I have my heap, sorry, my heap has the three elements which are 1 comma 4 comma 5, right? Now what I'm doing is I'm having one more pointer, and I'm
Okay.
using the same array and changing the values in the same array. So what I'm doing is my final array is 0 initially. So what I'm doing is I'm doing heap dot poll. What heap dot poll does is it will return me the smallest value in this heap, which is 1 in this case.
Okay.
Now I'm doing array of j. J is initially 0, so array of 0 is equal to 1.
Okay. Okay.
And
Okay. I
I'm
got
adding the new element to the heap. So right now my I was k plus 1, right? That is why it went out of this loop. Since k was 2, my I was 3. I was 3 meaning I was at the value 2. So I add 2 to this heap right now and increment the value of I by 1.
it. Okay. Nice.
Yeah. So now my heap becomes 2, 4 and 5. The
Yeah.
next
Sure.
iteration, my array of 1 becomes again the minimum value of the heap, which is 2. Similar to this, after this, I add 3 to the heap, remove 2. This poll actually removes the value from the heap. So when I'm doing poll, if I'm doing a poll right now, it will become this. And then when I'm doing add, I will add the next element to it. And I'll keep on doing this. And since I will finish first, right? So I will go out of bounds first. So if when I goes out of bounds, I will still need to add the remaining elements of the heap to the array, and that is why I'm doing like this element, so I won't add anything if I goes out of bounds.
Okay. Okay. So you can run the test, right?
Yeah, I'll
Okay.
just do that.
Try to run the test. It will be max channel now.
I'm just afraid about the heap functions if poll and oh yeah, it works.
This work.